Hello, hello, hello. Um, okay, so let's get started. Um, Welcome back to day 74. I think, anyways, it's been good. Slow progress is still progress. Anyways, thanks for um everyone in the stream. Hold on, I'm just trying to pull up my screen to see um you know how the live is going. Yep. Uh, it's been a very fast day. Today just went by very quickly. Before I could blink, the day was over. Um, okay, so as usual, I usually like waiting for like at least one person, two people, three, four, 5 people to be in the stream. Before I continue, so let's see what goes on. I'm just going to repeat certain things I did yesterday. I didn't have enough time to plan for this stream today. But anyways, sorry. Um I have one more. I'll just solve the question I started yesterday, right? The chair was too low. Okay, that is good. Finally. Yep. Oh. Dun. It's good to exercise, I think. All right. Um. Okay, so there are 2 people here. I think that's enough. I can get started with those people. So, welcome to the stream. Once again, on the daily data structures and algorithms study session. Um, so today we are going to have a look at some questions from LEETCODE and on queues, right? So we solved some queues problem yesterday. I think this question, yes, is what I did yesterday. Implementing a stack with queues, which is a very weird question, by the way, if you ask me. But anyways, no judgment, no judgment. Right. So the next question we'll be looking at today is time needed to buy tickets. Now I started explaining this question yesterday, but I'm still going to, re-explain and share my thought process on how I would solve this question. Right. So let's go ahead and read the question and see how we can go about this. So the question is 2073. That's the number. And so I read, time needed to buy tickets. There are n people in a line queuing to buy tickets. The 0th person is at the front of the line, and the n minus 1th person is at the back of the line. You are given a 0 indexed integer array tickets of length n, where the number of tickets that the ith person would buy is the ticket at I, right? So each person takes exactly 1 second to buy a ticket. A person can only buy one ticket at a time and has to go to the end of the line, which happens instantaneously, in order to buy more tickets. If a person does not have any tickets left to buy, the person will leave the line. Return the time taken for the person at position K, which is 0 index, to finish buying tickets, right? So we want to return the time taken for the certain targets, or this is the position of the person, right? So person at 2 will be this person here. The time taken for this person to buy their tickets, right? Now there is a bit of um, things to take note of. So let's pass in here. So I made this illustration yesterday and I was explaining how everything will play out, but I don't think I can still use this anymore. But I'll just remove this here and write out a new explanation. So I usually like illustrating, or in other words, visualizing the question before I begin solving it. So let's see what we can do here. So we are given an array of people and the amount of tickets they want to buy. So we have an array like this. So a list of people, this is 2, 3, and 2. Now the situation is such that when somebody buys a ticket, they go back in line, right? So let's say this person, right, the person in front here is this person here. Let me use a different color. Is this person. So each person has the number of tickets they want to buy, and you can only buy a ticket at a time, right? So when you buy your ticket, you go back in line, right, to wait for the next person to buy their own, and then it happens turn by turn. So the first person here buys their tickets, right? So this person here will buy their ticket and they'll go back in line. So we'll have 3, 2, and then after buying their own ticket, right, this is the current person, if the amount of ticket left for them to buy is 1. The next person happens again, so we'll have 2. This 2 comes in front now, 2, 1, and then 2, right? This person buys their ticket again, so this will be 2. This will be 1, 1, 2, and 1, right? And so on. So this person has one ticket left to buy. So after buying their own ticket, they will leave the queue. So it will be left to 2, 1, and then 2. 2, 1, and 1. Sorry, 2, 1, 1. Sorry, 2 and 1. And then this 2 buys their own ticket. So this becomes 1 and 1 like this. This person is done buying their own ticket. So it remains one person in the queue, this person to buy their ticket, and yeah, it's just one person left. So there won't be any more person in the queue, right? Now you can see there are different steps for us to continue the count. But when you what you notice is, if you look at this, right, this is step 1, step 2, 3, 4, 5, right, and 6. So it took us 6 steps, right, for this person here, or our target, to finish buying their ticket, right? So it will take us 6 steps. You know what? Let's use a better example. I'll leave this array and I'll make a proper illustration of what happens, like I did yesterday. So I'll draw 3 people, right? So we have 3 people in the queue currently. So the first person will be this person here. Let me just draw them like this. This person has 2 tickets to buy, so I'll put 2 here. The second person has 3 tickets to buy, so this is 3. And the third person has 2 tickets to buy, so this will be like this. All right, so when the first person buys their tickets, right, the amount of tickets they want to buy gets reduced, right? So, and it takes exactly 1 second for them to buy a ticket. So after buying their ticket, they'll go back in line, right? So I'll just come here. So it took them 1 second to buy the ticket. So after buying the ticket will be reduced by 1. I should have used a different color. This will be 1, And so far, it took 1 second to sell a ticket to this person. So let me just quickly come here. Okay, it took 1 second to sell a ticket to this person. So after buying their ticket, they'll go back in queue, right? They'll go back in line. So let me just do this. So this person will go back in line, and I'll just shift this forward. So this person will then buy their own ticket. Now, I would like to, before I move this person in line, right? Our target, right? Person at K was equal to 2, right? So it means we are targeting person at position 2, which is this person here. So the third person in the queue, right? So I will just represent that person with a different color. So that we can properly see what happens by the time they are done buying their tickets. So I'll just call this like this. So this is our K. K is equal to 2. So this is 2 here. This person wants to buy 2 tickets. So the first person buys their tickets, right? And the amount of tickets gets reduced by 1 because they've already bought 1 out of 2. So it takes exactly, so I'll put count here. Count will be 1 at first. And then the person moves back in the queue. So goes back in the queue. And then let's just adjust this again. This person here, number 3, this person wants to buy 3 tickets, right? So we reduce ticket number by 2, right? By 1, sorry. And they'll have 2 left. And how many seconds it took for this person to buy these tickets is 1, right? So we'll add 1 to the previous count. So we'll say this becomes 2. And then we move the person back in line. So this person goes back in the queue. And now it's our target's turn to buy a ticket, right? Again, the same thing will happen. The amount of ticket they want to buy gets reduced by 1. They have been sold the tickets. And we now have 3 seconds spent so far. So let's move back in line, and the next person buys their tickets. So this person will buy the last tickets they need, and the amount of tickets, gets reduced to 0, and then we have 4 seconds left, right? So since they don't have any more tickets to buy, so they will need to leave the queue, right? So we have 2 people left to buy tickets. So this person buys their own ticket too, right? And the ticket number gets reduced by 1, and we have 5 seconds so far. And this person moves back in the queue because they have more tickets to buy. And our targets, right? Our targets amount of tickets is 1, so they buy 1 more ticket, and the amount of ticket they need to buy gets reduced to 0, and the second becomes 6, right? So this person would then leave the queue, right? So this person leaves the queue, and it's just left with 1 person. This person to buy their own tickets in the next round, and they also leave the queue at the end of the day. But the point is, our target time taken to buy all the tickets they need is the sum of every ticket of every time spent to buy a ticket for every individual in the queue, right? Is the total sum. So at the end of the day, right, our count, the last value of our count when our targets, right, bought their ticket will be what we need to return in our function, right? So here is what the question is asking us to do, right? So the total time taken for our target to buy all the tickets they needed was 6, right? If you look at this place here, you can see we have 6 seconds spent, right? So what do we do next? Well, we need to understand a few things, right? In terms of programming, how we need to program the steps taken for each member to buy their ticket, and also look out for when a ticket is finished for our target, right? When the target got all the tickets they needed. Our target is the value of k, right? So I'm just using it as target for now. Once our target has no tickets left to buy, we need to stop counting the time taken for them to buy all the tickets they needed. So first thing that came into my mind is we need to first of all run a loop, but the kind of loop we need to run is also um, something to think about, right? First of all, we know we want to keep reducing the value of every person, the number of tickets every person has to buy until they no longer have any more tickets to buy, right? That's one thing we need to know. So this step is not really going to be for every value in the tickets list, right? For every amount of tickets each individual wants to buy, but instead we need to iterate based on the amount of tickets left for each individual, right? So how do we do that? Well, there are a few ways we can do that. We can use the total amount of tickets um in the ticket list, or we can run a while loop, right? A while loop, and constantly keep the loop running until the condition for us to exit the loop had actually happens, right? So we need to also take that into consideration. Now, the third thing we need to also know is how to reduce the value for every uh, person that buys a ticket, and also move them back in the queue, right? So in this case, I don't think we need to stress too much about it. There's a simple way actually that we can use to do something like this. Instead of us moving the people, I mean, instead of us moving each person back in queue, we can keep them like this and iterate every time and reduce their value by one. So in the first iteration, we can do something like this. For every value here, we'll do -1, I mean 2 minus 1 will be 1, 3 minus 1 will be 2, 2 minus 1 will be 1. 2 minus, sorry, 2 minus 1, yes, 2 minus 1 will be 1. So it took us 3 steps to reduce the value of every individual, right? Or the amount of tickets each person wants to buy. It took us 3 steps. So the first iteration will take us 3. Now we are also going to continue the iteration as long as our target, right, still has more tickets to buy. So the next time we iterate again, the value of each one of the tickets that every individual has to buy gets reduced by 1 again. So this will become 0, this will become 1, and this will become 0. Again, it took us 3 steps to do this. Now, not only that it took us 3 steps to do this, but something happened, right? Our target now no longer has any more tickets to buy. So meaning the value here, right, has to indicate to us that, okay, there is no need to continue reducing, because we want to know how long it takes the person to buy all the tickets they needed. And it will simply be equal to 3 plus this 3 here, which is equal to 6. So the total time taken for them to buy all the tickets they needed while other people were also in in the um in the queue is 6, right? So before we get into the coding part, I would like to check if there are any questions. Um Yogesh said hello. Yes, hello, how are you doing? Welcome to the stream. Okay, so that's practically what needs to happen in this question. So, as usual, I'll pull up my code editor and try to write out some code for this. This is a stack related question, so I'll leave it in the queue related question, so I'll leave it in the queue folder. And this is question 2700, right? Question 2700. 2073 2073 2073 2073. Okay, sorry. I usually do delete leet-2073 num of, sorry, what was the question again? The title, time required to buy. Okay, I'll say this is going to be time required required to buy ticket. Mm-mm. Christ, what am I doing? Oh God. Okay, so let's see going on in the chat before I begin solving the questions. So there are no questions so far, so we can go ahead and continue solving. Um, I don't know why I'm beginning to, have like very heavy brain. Like my eyes are shutting down literally. Mm. Sorry, a second, please. Sorry. Okay, so let's see. Uh, oh, my sound is very low. Wow, I did not know that. So sorry. Um, can you hear me now? Can you hear me now? If you can hear me now, I'll be happy. Um, anyways, thanks for pointing that out. Um, it's really good. Okay, so let's carry on. I'll begin solving the question. I'll begin solving the question now. Right. Thank you very much for answering. Okay, so here's what we need to do. I'll copy the boilerplate of this question, and then so we'll go through the steps to solving this question. So I'll import this here. Now, first of all, we want to return a count, the amount, the time spent, right? The time spent for the individual at position K to buy all the tickets they needed. So first of all, create this. I'll call this time. Sorry, this is going to be equal to time. Time will be set to 0 at first because it takes at least 1 second, right, to buy a ticket. So that was the condition the question gave us. So let's work with that. Now I'll run a while loop, right, to keep the reduction of every amount of tickets each person wants to buy, right? I'll just, so here's what we need to do. Let me show you. So for I in range, in range, so we'll use the length of the number of the ticket, sorry. The tickets, what's this? Yes, so tickets. Why is this not coming up? Length of oh, sorry, for I in range, length of tickets, right? So we want to reduce the value of every ticket in every iteration. So we'll just say tickets at I, right? Minus equal 1. Now, this is what we need to do for every iteration, as long as our target at K still has more tickets to buy, right? So meaning we need to reduce the value for every one of them, and each time we are reducing, right, we will increment the time, right? So time will be plus equal 1. But then again, there's something else we need to keep note of. If somebody does not have any more tickets to buy, they need to leave the queue, right? So we need to check, because in this case, if we don't put some conditions here to reduce the amount of tickets every person has to buy, then we'll end up with negative values, right? Let's say, for instance, the first person has 1 ticket to buy. So after reducing the value of the tickets they want to buy, the amount of ticket they want to buy by 1, then they don't more have any more tickets to buy, right? So which means we need to remove them from this equation. We don't want to keep reducing the value though when the person does not have any more tickets to buy. So here is something we need to do. We'll say if tickets at I is superior to 0, then we need to do this. If ticket at I is superior to 0, we need to reduce the value of that ticket, right? The value, the amount of ticket the person wants to buy. So this part is basically saying, as long as the person has tickets to buy, right, reduce their tickets by 1, right? The amount of tickets they want to buy by 1, and increase the time by 1, because it takes 1 second to buy a ticket. So if this is the case, then do this, right? Now we also need to check if the ticket at K, which means our target, right, is equal to 0, right? We want to stop the iteration, right? Is equal to 0. We want to stop the iteration altogether. We want to end everything. So if we want to end everything, we can just say return the time, right? Return the time taken for them to finish this. All right, so here's something interesting that happened, right? That happens, when we want to reduce the value of every ticket. But then we need to keep this loop, this function, or this logic running as long as our target still has more tickets left, still has more tickets left to buy, right? So let me explain what I mean by that. First of all, the logic I just wrote, the for loop, right, will do something like this. So in every iteration, right, we want to reduce the value of the ticket to buy. So we have 2, 3, and 2, right? So we want to be reducing the value of each ticket by 1. So in the first iteration, right, we'll do something like this. So we'll reduce the value of 2. So 2 becomes 1. We have 3, 2, like this. Second iteration, we'll reduce the value of this. So this becomes 2 and 2. Third iteration, 1, 2, and then 1, right? So we are reducing the value of every ticket, every amount of ticket by 1 in every iteration. Now, and we do this by index, right? So by using the index of the value. So the first value in the current iteration will be reduced, the second, and so on. But this will happen just once. We want this to happen as long as our target still has tickets left to buy, right? So meaning this for loop is not enough for us. So we need to do something else. So we need to take this, right? So I can say while the tickets, we can say while tickets at K, right, is superior to 0, right, we want to do this. So whilst the tickets at K is superior to 0, we want to keep running this, right? Now, in the case where we are iterating and the amount of tickets is now equal to 0, we can return the time at this position. Otherwise, we can return the time outside, right? So let's say we stop the iteration. and can say wow. Oh, sorry, we can just do return time like this. So let's see what this gives us. I'll run this solution. You know what? I usually do this all the time, but let's call this solution and say the solution class. Let's create an instance of that class, and I'll do this. I'll say print solution dot sol dot time required to buy is 2 3 2 and then 2 like this. So let's see what happens. Now you can see we have 6, right? So it means it took us 6 seconds for our person at K, right, to buy all the tickets they needed. So let's try this out in LeetCode and see what happens. I'll just copy this. Da, 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 da. Okay, so this is alright. This is alright. So let's run this and see. Now, the time complexity for this, let's talk about big O, right? The time complexity for this solution, first of all, with this while loop is O of n. And then we have another for loop within the while loop, right? A loop within a loop usually results to an exponential time complexity, and in this case is going to be O of n squared, right? So I'm not sure if there is any metrics put in place for so there are no, the constraints are that there is always an item in the array, and well, n equals to is simply representing n by the length of the array, and this is going to be okay, so at least one item in the array. Okay, and also we have the value of each element between, so they are all positive numbers, right? We can't have a negative number or a negative amount of an item. So okay, let's submit this and see what happens. Okay, you can see this solution works, but the time complexity for this solution is very low, right? I mean, the performance, right? The runtime is really low, 6.5%, which means like one of the worst solution out there. So I think there is an editorial available for us to actually improve this question, but I'll read through and see what we need to change. You know what, there's no need for me to read everything. I'll just read some parts and see what we can do, right? Now this solution here is a simple brute force solution. I will just put it that way, but let's look at how we can solve this using a queue. So overview, right? We have a queue of people who each want to buy a certain number of tickets. We are given an array where the elements represent the number of tickets each person wants to buy. We need to find out how much time it will take for the person to buy a specific position key in the queue to finish buying their tickets, right? So key observation, each person takes exactly 1 second to buy a ticket. A person can only buy 1 ticket at a time before going to the back of the line, right? Each person has bought all the tickets they want. Once a person has bought all the tickets they want, they leave the line. The order of people in the line is fixed meaning the person at the front, which is at position 0, gets served first, then the person behind them, and so on. So, simulation using queue, right? Intuition says we can simulate the ticket buying process by using a queue of indexes. We dequeue each person from the front of the queue and sell them a ticket. If an individual still needs more tickets, we enqueue them at the end. Okay, that's good. Um, in summary, we simulate the process with a queue containing the indexes or indices of people in tickets and iterating until the queue is empty. Hmm, that's interesting. In each iteration, we dequeue the front person from the queue and sell them one ticket. If the kth person has bought all their tickets, then we return the time. Okay, so if the person at K bought all their tickets, we return the time. After processing each index, we add it back to the end of the queue if the corresponding person still needs more tickets to buy. Okay. So we have this note I symbol with dot indicates the perspective or point of view from which the queue container should be observed. I symbol. Okay. So we initialize the queue, we iterate through every item in the queue. I think I can do this with queue, right? I can actually do this with queues. So all I needed to do. Sorry. So we get the front elements from the queue, decrement the front by 1. Mm, it's just like what we did yesterday, right? Here. This one I think counts the number of students, yes. So and the condition to break this is if any students does not like the sandwich at the top, we stop the queue. But in this case, if there is, so we can run for every student in the queue and then and queue them once for every person in the queue. Sorry, and then queue them back to the queue. And I queue them to the queue after buying a ticket, and we reduce the count by 1. I think that will work. So, um, if person at index K has bought all their tickets, right, front and K will be equal to 0. Hmm. I mean, sorry, I just blacked that a little. Uh, okay, so return the time if there are more tickets. You know what? Let's do this. Let's do this. I'm not going to look at the solution, but I understand. We could use at least a queue to do this. So I'll call this brute force solution. Rename. I think refactor rename. I'll call this. Let's call this brute force. Brute force. And then we'll create an actual one for this. So say here. Okay, we need to implement a queue and simulate the dequeuing process. A minute, please. Okay, so let's say I'll copy this part of the code. Let me just copy all of this. Because, this is not even the question I needed. is this one here, the brute force solution. Okay, I need this part like this. I'll put this here. You know what, you can also remove this. I don't fancy putting solution class anymore. So let's remove solution class here. Serves no purpose. So self is gone as well. So we can create a queue of student or a queue of people, right? I'll say people queue, people, or okay, let's call this tickets queue, right? And said is, so we'll use the deck class from the collections module. So I'll say from collections import deck, and we'll use the deck to create a queue of tickets to buy. So this will be queue, and we need to pass it the tickets. Sorry, deck this tickets like this. And what we need to do next is to iterate and reduce the value of our target. So we know our target will be at position K. So we also need the time count, right? Time will be equal to 0 at first, but we need a loop. So I'll use a while loop. I'll say while tickets queue at K, right, is still superior to 0, then we'll begin the reduction process. There is something funny that will happen in this case. If hold on, oh my god. Sorry, I had an emergency to attend to. Emergency call. Okay, so if we do this right, and we kind of change the position for every person in the queue. So let's say we dequeue somebody and then enqueue them back. I don't think this will work like this, because person at K, right, might change. Here's what we need. Here's what needs to happen. So we'll say if I mean the ticket queue, right? The person at the current person has more ticket to buy. So this will be the top person, right, in the queue. If they have tickets, they still have more tickets to buy, which is superior to 0, then we just do ticket queue at this place, right? At 0 minus equal 1, then we would dequeue this person. So we dequeue them, we'll dequeue and then enqueue them back. So we'll say ticket queue ticket queue dot append. We can use append. No, we are not appending, but wait. When you dequeue, we want to add it to the back, right? So okay, so append ticket queue dot pop left. So we'll do pop left. Okay, so it means we remove the person in front and add them back to the queue, right? As long as they still have more tickets left to buy, right? So then in the next iteration, the first person will be the second person previously, right? So we'll do the same thing, queue append left and so on. Now there is a problem with this. So and also every time somebody buys, we need to increment the time. So I'll say time plus equal 1. The problem here is that this ticket at K, after doing, enqueuing somebody we just dequeued, ticket at K will no longer be our target, right? So what do we need to do in this case then? Let me read this again. So it says increment time by 1, get the elements from the front of the queue, right? Decrement ticket at front, okay? The element at the front of the queue is going to be 0. So by 1 to buy 1 ticket for the person at index front, and if the person at index K has bought all their tickets, then K is equal to front. Oh, and front. Okay, so we need to use a front and if K is equal to front and front is equal to 0, ticket at front is equal to 0, then we return the time. If there are more tickets to buy, re-add the index front to the end of the queue. So queue dot add front. This is interesting because if the person at index K has bought all their tickets, right? Now we're using front. I mean, front is the, let's see. Front will be the item, the ticket in front in the queue, right? So meaning this would probably be 0, right? Because front is the first item in the queue, so this will be 0. We reduce this by 1, which is what I did here. So we are reducing this by 1, and then we are adding them back to the queue because they are not equal to this thing yet. My problem now is the index K, because after enqueuing somebody new, let's say in this case, re-add index to the front, right? Index front to the end of the queue. So after enqueuing somebody from the front, index K will no longer be index K, right? So meaning we are mutating the array or the list at this point. So I'm not sure. Let's take a look at this thing here. So we have so initialize the queue. So you're using deck. Okay, that's good. Deck dot append I. So len of tickets. So every I here. We are adding the indexes. That's strange, but anyway. So while there is a queue, each index is time plus equal 1. So front will be pop left. Well. That will be equal to left. So first of all, we're adding every index in the array. So we have 1, 2, 3, 4. Okay. So we have 3 items. So our queue has 3 people in the queue. So this will be the queue. While there's 3 people in the queue, we increment the time each time, right, for every iteration. And we set front to the, pop left, which is the first person in front. So we do ticket at front -1, right? Uh, if the person at K bought all their tickets, right, ticket front equals to 0, then return the time. Okay. So that makes sense. So first of all, we remove one person from the queue, right? We remove one person from the queue, and then we reduce that person, right, from the queue by 1. So this, in the first situation here, this would have been 1, right? I mean, so this will start from 0. So this would have been 0. So person in front, okay, will be in index 0. Okay. And then we'll do -1. So we reduce the value by 1. So that was going to be equal to 1. And if K, so what is K here? Okay, so K is the, okay. If K is equal to front, K is equal to front will, and okay, ticket at front is equal to 0, return this. If ticket at front is not equal to 0, queue.append front. Okay, this makes sense now. I think if the ticket in front is not equal to 0, right, queue.append front. Front will be indexes. Yes. And interesting. Okay, so let's take a look at what's happening here. So this is the improved version of the code. First of all, here's what they did. We add all indexes to the queue, right? We'll add, from 0 all the way to the second index. And then each time we iterate for every value in the queue, right, we increase the time, because obviously we'll perform some operations here, which is buying a ticket. So front will be the queue pop left. So we are removing the first item from the queue. So in this case, front will be equal to 0. Now we are reducing the value of the first item in the queue by 1. Front here, remember, front is simply going to return an index. So if K is equal to front, right, which in the first iteration is not going to be until we reach the kth item in the list, then we take the ticket, and we know the ticket at front is equal to 0, right? Then we return the time. Otherwise, we take that ticket and append front to the end of the queue. This is very interesting. So let's take a look at this. I'll just do this way. So say ticket queue, this and that. This is okay, but we are not adding the tickets directly to the queue. So let's iterate and add that to the queue instead. You know what? Let me just play this out. I'll say for, let me see. Okay, so okay, let's remove it. Say time is going to be equal to 0. In fact, we can create time at any point, but yeah, let's just do it here. Say for I in range, the range length, for I in range length of the queue, length of the ticket, right? So we want to add every ticket into a queue, so we'll create a queue here. I'll call this queue again, queue is going to be equal to, or let's say I'll call it index queue. Okay, this will be index queue, and this is going to be a deck. So all we need to do is to say index queue dot append I, right? So we are appending every index to the queue. So the next step is to iterate through the queue, get the first index, and check if that item, right, has already been reduced to 0. Otherwise, we reduce it by 0. We reduce it to 0. So we'll say we reduce it by 1. Sorry. We'll say while there are still people in the queue, while the queue is still there. I'll say while index queue. While index queue, while there are still people in the queue, we want to first of all, the time is going to increase regardless of whatever we do. So plus equal 1. Now we'll take the front person. The front person here this time around is going to be equal to index queue, right? Index queue dot pop left. Okay. Now we also need to have the target, the person we are targeting currently. So our targets can be so we'll say targets is going to be equal to the person in front. So ticket front. Okay. Now the next thing to do is to find out if the current person, right, is equal to k, and if they no longer have any tickets left. So say if k right is equal to front, and the target is equal to 0, then we return the time. Otherwise we continue. So say else here is what we need to do. We'll take the person in front and add them back in the queue, right? But then we have to reduce their value by 1. So we'll say target again. Target has to be so the value here, so we need to change the value here. So we'll say, target is ticket in front, right? We can do this. We can say target minus equal 1. This will mutate the array. So you know what, let's do this. We'll say, I just want to be sure, target tickets at front, right, minus equal 1, please. Okay, so the internet was really crap for a second. Anyways, so we'll say we want to append that person in front. So append front here. Okay. So yeah, so that's basically what is done here. And we are also doing the same thing here. So okay, so if it's not else here, we have to check also if the ticket here ticket in front is not equal to 0, then we append the person back in the queue, right? But then we need to reduce the ticket by 1, right? So the ticket was reduced by 1 already. Okay. So let's see. This will work, but you know what? Let's just do it this way. So we first of all, if the front is equal to target, target is equal to 0. Yes, I mean, our target here is equal to 0. Our target is ticket in front. So ticket in front minus 1. I don't think reassigning this value here will do something. But targets will not change, mutate the value here. So we just keep it that way. Reduce target by front. You know what? Let's remove this first. I'll comment this out and just go with this before we do this. Now we need to check not this. So we'll say if our targets, if here ticket in front is not equal to 0, then okay, it's not equal to 0. We dequeue and then queue the person back. So we already dequeued the person from here. We remove them, right? And we check if the ticket in front is equal to -1, right? If we reduce the value of the ticket in front to -1. Now, yes. So if k is equal to front, right, and the ticket at this current position in front is equal to 0, then we return the time. We also need to do this. I think k front -1. There's something else I wanted to check, but I don't think this will matter at this point. If front is not equal to 0, if front is not equal to 0, append them back. Okay. But what if we reduce beyond 0? I mean below 0, right? Wait. Tickets in front, queue, blah blah blah. I mean, would there ever be a case where we are not really concerned about negative numbers, but I don't think it will be. If the ticket in front is not equal to 0, okay, so if it's not equal to 0, we append them back. So already here we say if it's equal to 0, so we will never reach that case where there's a negative value, right? So okay, this is good. This is good. So you can see. So first of all, we take the first person from the queue. We check their value. We reduce the number of tickets they want to buy from the ticket list, and we check if the current person is the targets that we are looking for, right? And reduce the return the time here. Otherwise, we might have done that already. We can still return the time here, right? I'm not sure. So return time. I mean, is this not enough? Do we need to do this here? Do we need to do this? I'm just trying to improve my solution right now, and this is really funny. But anyways, so we return the time, right? In case we've reduced past, we didn't return the time here, right? I mean, return time here, we'll return the time if this condition was true. Otherwise, we will still return the time anyway. This will end the loop here. This will end the iteration here. So that is good. Let's run this and see. I'll copy this code. And let's see. Now the time complexity for this, let's say we have this loop here, O of n, another loop here, O of n as well. So let's say O of m and O of n, right? Two different loops. O of n plus n, right? Okay, so we have runtime error. We say time is equal to 0. What's going on here? What's going on here? Da 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 da. Dun 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 dun. What's this? Runtime error. It says indentation. You know what? Let's do this. We don't have indentation error again. We can just shift this inside, but I'm not going to do that, obviously. I ain't gonna do that. So we just take this, tab, and go. Oh, we can't do that. I can't do it that way because I've removed certain things here. So let's just indent this instead. Okay, so let's see. Yeah, you can see I said plus is times. Well, this solution is still not very good, but I'm just going to end my stream here today. I need to go. So git add. I promise tomorrow will be a longer session. Git commit dash m. This will be what? Queues 2 lit 2073 LEETCODE lit that's 2073. Come on. Main. Push to main. The main branch. Okay. I think tomorrow I'll prepare very well for tomorrow because tomorrow is Friday and tomorrow has to be a special day. Anyways, thank you.